Hi all, I'm Revati from Sales Department of Technology. Today, I'm going to the lecture cryptography network security, Unit 3. And first topic is prime number and what is prime number. Prime number, it has prime number. It should be divisible by 1 and itself, that is called the prime number, and which has a divisor of 1 and self, and it cannot be written as a product of other numbers. So like 2 3 5 7 are prime number, and 4 6 8 9 are not a prime number, and it is sent to number theory systems. So we have I'm giving the prime number which is less than 200 is listed here. Kindly look for this. And the next one is prime factorization. Prime factorization is a number which has the multiplication of two numbers, which gives the product of prime number, and the two numbers should be a prime number. And to factor the number n is to write as a product of this number, like n equal to a into b into c. So note that the factor number is relatively hard, and multiplying the factors to generate the number, and the prime factorization of number n, which is written as a prime product of primes, written as the product of primes. So for example, 91 is a prime number, means it is a product of 7 and 13, and 7 also should be a prime number and 13 also should be a prime number. Next one is Fermat's theorem. Fermat's theorem, Fermat's theorem, which is used to find the prime number, which is used to find a prime number, and it is an abstract one. We cannot say a detailed theorem of here, because Fermat's theorem is which was developed by Fermat, and a lot of information after the lot of information he developed the Fermat's theorem. So here we are going to see abstract view of Fermat's theorem, and here we have theorem a per p minus 1, which is congruent to 1 mod p. So where p is a prime number and a and p should be a prime number. Go prime or relatively prime, we should give the value of greatest common divisor of 1. It is also it is a Fermat's theorem. So another one, Fermat's theorem is a power p, which is equal to p of mod p. It is used for public key primality testing. Here for that we are using here prime Fermat's theorem. Next one, Euler's torsion function. It was developed by Euler, and here we are using the we should take the value of n value, and it has a 0 to n minus 1 value, and these numbers which are relative prime to n, for example n equal to 10, so we should take the value of 0 to 9. In this 0 to 9, what is the prime number is 1379 is the prime number, and we have some rule of Euler torsion function, which is a power phi of n, which is congruent to 1 mod n, and a and n should be co-prime or relatively prime, and phi of n is a Euler torsion function. Phi of n is a Euler torsion function. To compute the phi of n, we need to count the number of residues to be excluded. So here phi of p equal to p minus 1. We should take the both phi value. Phi of q equal to p minus 1 into q minus 1. So phi of 37, for example, phi of 37 equal to 36. Phi of 27 equal to, we can 7 3 is 21. So we are using the formula p minus 1 into q minus 1. P minus 1 into 7 minus 1 equal to 12. So phi of 21 is value is 12. Next one, the Euler theorem. Already I said a of phi of n, which is congruent to 1 mod n. Hence example 3 power 4 equal to 81, 1 equal to 1 mod 10. Hence we should get the value of 1. And primality testing, it is used to find the large prime numbers. And it is used to divide all the numbers in turn less than the square root of number. It only works for the small numbers. So it is used for all the prime numbers satisfies this property. And some composite numbers also called pseudo primes, which is also satisfies this property. It is used for testing the primality. Next one, the Chinese remainder theorem. Chinese remainder theorem, which is used to speed up the modular calculations. And if we have a five steps here. For Chinese remainder theorem, for take the value of x. If we not know the value of x, we should divide the value of n1, n2, n3. So here we are getting the remainder 1, remainder 2, remainder 3 respectively. So we should find which pair should be the co-prime. So if any two pair is a co-prime, and using that we can find the value of x. So it is used to speed up the modulo calculation. Mod m equal to m1 up to m2 up to mp. Chinese remainder theorem work for each model mi separately. Since computational cost is proportional to the size, so it is faster than working in the full model. And this is the Chinese remainder theorem. First step, we should calculate the m value. M value, which is equal to a1 into a2 up to an. And second one, we should calculate the mi value. Mi value equal to capital M divided by small mi. And here the formula, a equal to congruence to summation of I equal to 1 to k. A is a into mod m. And discrete logarithm, it is a problem to exponentiation is to find the discrete logarithm of a number of model of p, and it is used to find this x such that y equal to g power x mod p, and it is also written as x equal to log y of mod p. And using this we can find the logarithm value of logarithm value. After that we can find the x value. Thank you.